I'm good. All right. Thank you. I'm very happy to be here today to sort of finish summarizing NOIRLab's time domain capabilities. So we are building an automated end-to-end system for time domains so that the users, a lot of you, can really focus on getting your science done and not worry about the plumbing underneath that we're trying to build. So fortunately, our speakers the last 2 days have covered a lot of these things. So I'm able to spend my time today talking about the Gemini capabilities, which haven't really been mentioned yet. So a brief introduction to Gemini Observatory. We run twin 8-meter telescopes, coverage of both hemispheres from Hawaii and from Chile. We're an international organization. We have 5 full participants. We have the 2 hosts, Hawaii and Chile, and we exchange time with different observatories. Right now, we're exchanging time with Subaru. Also, notice in the pictures the solar panels. Sustainability is very important to us, and we're undergoing a big sustainability program, which by 2027, we want to reduce our carbon footprint by 50%, which includes Rubin operations. So we're basically paving every rooftop and large portions of Pachon with solar panels, as well as other efficiency improvements. So we offer a variety of observing modes, emphasized or really dominated by Q or the service mode, where the staff take the observations for the users in the appropriate conditions. And you can look over our shoulder with Zoom as this eavesdropping mode if you'd like to. We still have classical or visitor mode, which is not requested very much these days. It's mostly used by visiting instrument teams. But we do like people to come to visit the observatories and we interact with them. And so before the pandemic, we had this priority visitor mode where you come for a block of time, say a week or 10 days, and you can observe your observations, when the conditions are appropriate, and we do queue backup otherwise. And hopefully we'll start bringing people back soon. One thing to note is that we do now all of our observations from the base facilities rather than the summit. Just to make it easier, especially on people in Hawaii, because observing in Mauna Kea is tough. So if you have a proposal idea, we accept all sizes and on a variety of timescales. We've got director's time and poor weather proposals can be submitted at any moment. Poor weather is for things that can take the poorest image quality and cloud cover conditions. But if you have those bright targets, this is a great way to get a lot of data, basically for free. We also have the fast turnaround program with deadlines once a month. Good for sort of smallish projects, or if you want to do like a trial program or finish up some other observations. And those programs last for about 3 months at a time. Then, of course, the regular semester process and large and long programs for more ambitious activities that last up to 6 semesters. On the NOIRLab side, director's time, the regular semester process, survey proposals for several year projects. And one thing to note is the U.S. has open skies policy. So if you don't have collaborators within, say, the Gemini participants, you can always apply to access these capabilities via the US. As mentioned yesterday, the NOIRLab TAC process will also allocate time for the Rubin in-kind contributions, and most proposals now evaluated the dual anonymous review process to reduce bias. So due to our Q mode, Gemini has always done a really substantial amount of time domain astronomy over the sort of history. Between 15 and 25% of the time in our band 1, which is the highest ranking band, is target of opportunity observations. This is set by the demand of the users, the proposers, as well as the tax. But we want to be prepared and have to be prepared for an increase due to the LSST alerts. So that's what we're trying to prepare for. Just so you get to have the nomenclature right, we have also 2 types of TOOs. There's the rapids, just similarly to the ESO hard TOOs, which must be executed in the upcoming night, next 24 hours, no conditions constraints, and they can interrupt when needed. The standard TO is more common. It can be executed anytime after the trigger. Usually it's a couple days later. It can be in any band and take the different sets of conditions. So the main instruments that are used for time domain are our facility, workhorse instruments that are on the telescope most of the time, although almost all the instruments can be used when needed. This slide shows the expected instrument suite in about 2 years. So at Gemini North, the most likely facilities you'd use are GMOS North, which is an optical imager and spectrograph, and GNIRS, which is also infrared spectrograph, but it has some imaging capability too. In the south, there's GMOS South, which is a copy basically of the northern one. Flamingos 2, which is a near-infrared imager spectrograph, and Scorpio, which is an instrument that I'll mention in just a bit, but it's a optical and near-infrared imager and spectrograph. You can also do, especially standard TOOs with our AO systems. There's a little bit of delay, a few days, because we have to approve the targets. So a little bit on Scorpio, which is under construction. It's basically being built as a Rubin follow-up machine with coverage from the G band to the K band using 7 dichroics. You get simultaneous 8-band imaging over at the most a 3 arc-minute field. Of course, you can have a smaller field and read out faster, or single object launch slid at R of about 4,000. So it's a little bit like X-Shooter in that mode. So it's designed or hoped to be operational by the start of the Rubin alert stream by the end of next year. So we've heard a lot about AEON, and Gemini Current works within AEON through a plugin we have for the TOM Toolkit and an existing set of APIs that we have. The TOM Toolkit plugin allows you to submit observation requests to Gemini and use all of the automation capabilities within the TOM Toolkit. The API works as far as it goes, but is rather limited, and we'd like to improve those capabilities. The Gemini Observatory Archive also has a set of archives for downloading the data. But we want to better support AEON and make life easier for everybody. So we are going to do this via a set of very ambitious projects. One is the Gemini Program Platform, and one of them is called Gemma, and I'll go over some of the details of this. The Gemini Program Platform, or GPP, is the core of a new high-level operating system for Gemini. It's designed to make it easier to use. It replaces the current desktop applications, the phase 1 tool and the observing tool, with a set of web applications with APIs to a database in the cloud. It'll allow Gemini North and South observations in the same program. Provides a lot of automation using experience we've had over the last 20 years of Q observing. Provides constraints we need for doing an automatic scheduler, and makes the code a lot more modern and maintainable. So this just gives a little screenshot of the main Explore app, which is the new sort of phase 1, phase 2 combined tool. And one innovation in this is it allows you to find our capabilities that meet your science needs without having to go through all of our instrument web pages and various tables or run the integration time calculator separately. It's all built in. You enter the mode you need and the constraints you have, such as wavelength, the resolving power you need, signal to noise, and it will search for the capabilities we have that meet all of those, run the integration time calculators, and give you exactly how long it's going to take. You select one of those. It's created all the calibrations and the sequence needed to generate that under the hood. If you don't need to do any modifications to that, it's ready to go. Your phase 2 is done. So we see this as a new way also of doing TOOs, and I would have to create some templates beforehand. You just generate the things on the fly based on what you need. And this is all API driven. So anything you can do with those UIs, you can do programmatically with your Python scripts or in a TOM toolkit. You can get all your program information, add, edit, remove targets, create TOOs, and so on. So again, this is we see as the way forward. And so a few months ago, I spent about a day and created the first version of a TOM Toolkit plugin that uses this GPP API. So I'm just going to give a little example of what it does at the moment, how this works. So I've created a filter to do an ANTARES query, which will give me a target, which I think will work nicely in this demo. Here's the light curve in ANTARES. It looks like maybe it's a transient in a galaxy. So I'm going to see need to know more what it is, so I import it into the TOM here. I'm going to add it to the database. There it is. I'm going to see if it's visible at Gemini. It is. So at the moment, I just picked the program I want to use and submit it. It creates a new target. If it doesn't already exist, it creates an observation with that target. Now there it is in the database, and then I flip over to Explore. There's the new observation with all that information. So that's sort of as far as it goes at the moment. As I have time and the API is developed, of course, we'll add instrument configurations and constraints, other things like that. So we expect to start early use of GPP, especially early testing this year, actually within hopefully a month. We want to be doing the first nighttime observing with GMOS. Then we hope to have called XT1. It's a special call for GMOS imaging and long slit in about May, which may be up to 100 hours per telescope. So we really get a good evaluation, get a lot of people using it, get feedback, test out our scheduler, hopefully. And then over the next year, as we implement new instruments and modes, perhaps convert some existing programs into this system so we can try that out. And the current need is that we to start operations with this system by the end of 2025, really limited by the arrival of new instruments, which will only be supported here. So we're implementing real-time scheduling and data reduction as part of this NSF-funded GEMMA, or Gemini in the Area of Multi-Messenger Astronomy project. The scheduler is under construction in parallel with GPP. It'll update plans in real time as TOOs come in, as weather changes, creating plans for both telescopes within about 10 seconds. And this is an example from our schedule app of the output of that. Of course, as I showed, it has more capable APIs. There also is real-time data reduction that's happening within our Dragons pipeline Python environment. All facility imaging and GMOS long slit is supported at the moment. Quick look reduction for quality assessment we're using at the telescope, and real-time quick look of TOOs is almost ready. It's under final testing. Hopefully we'll have it operational sometime this year in 24B. And we have updates to the archive so it can handle processed data. We're also going to be adding the archive interface and Dragon support to the TOM toolkit environment via GOATS project. It's called Gemini Observation and Analysis of Target System. It's another project supported by NSF supplemental funding. And it's built on the TOM toolkit, so it uses all the connections to the brokers. It will use the GPP plugin to submit observation requests and communicate with GPP. It's adding the connections to the observatory archives. You can download the data, reduce it with Dragons, and we'll have also interactive analysis tools done in a modular way, so these can be added to other existing TOMs as well. So a little bit about policy, which may be of interest. Our experience with first Kilonova follow-up led to a new policy for competitive TOOs. We don't have a single follow-up program. It's like every partner has one or two programs to doing Kilonova follow-up. And so they all collide when one happens. So we define this, the priority. Pre-queue programs get priority of DD. If there's multiple requests for the same target, we try to work with people to make a plan if it's possible. Otherwise, it's basically take data first and figure out everything else later. But there are rules for prioritization. Basic is by band and the order we receive things, and we will share the data when people ask for the same configuration. But we're always interested in improving our policies, in last October, we discussed a lot of this at the Windows on the Universe MMA workshop that was held in Tucson. A few of you were there. And one thing, the white paper from that meeting is now out on the archive, so check that out. There's a lot of good recommendations there. But at the meeting, people were pretty clear to us about what they didn't like about our doing TOOs at Gemini, and gave us some suggestions which we're considering. For example, allowing the rapid TOOs in lower ranking bands. That would be fine as long as you understand you might not get your data. There might be a higher ranked proposal that gets it instead. But I see this as being less of an issue once the scheduler is in place, because the difference between rapid and standard will start to blur, because you'll be able to schedule it as soon as it's submitted. Another suggestion was that we have key projects or special projects for some of these rare high demand types of targets like kilonovae or interstellar objects that everyone wants to observe. The idea was to really promote inclusion and either have something that's led by staff with a lot of community input, such as the HST Ulysses effort, or have it be community led, but have some sort of either DD or large program that would act as sort of queue overfill. So other TO programs could be in the queue, and when one of these rare events happens, then we have something to do immediately. One idea is that the proposal would be published somehow and citable, so that when the data is released with zero proprietary period, just released to the public, if you use that, you need to cite this proposal. That gives some credit to the people on the team and promotes sharing. If we do that, of course, we probably need to discourage some directly competing proposals. So those things we're considering. I was sort of hoping we might be able to implement something for 24B, but it's more likely that think about this a little more deeply and do something for LIGO 05. So in summary, NOIRLab has and continues to develop this suite of facilities, including time domain surveys, alert generation on both Rubin and the Blanco, telescope coordination, new instrumentation, pipeline environments, to really, so you have an end-to-end system for time domain. As mentioned by Carrie, the SOAR and Blanco have these now Q-based AEON mode, and we're adding new instruments and telescopes every year. Gemini is constructing this new observing system so that we can better support follow-up, be more flexible, and make Gemini just easier for all the science. And we're interested in listening, collaborating, and sharing ideas, why I'm here. So thank you very much.
Well, thank you.